If you look around our universe, you can see that it is permeated by many shining galactic filaments and wars. Between them, there are vast stretches of the deepest space, hundreds of millions of light years in diameter, called voids. These tremendous gaps in space reach such an incredible, mind-boggling size that the largest galaxies appear like grains of sand in comparison, and some stars burn out completely faster than a photon travels from one edge of this abyss in space to the other. Even the omnipresent echo of the Big Bang dies down in their vast depths, which hold many secrets and mysteries. That means it's time to go to the very heart of the great abyss in space called Void. Kosmo. The first in outer space. Even after many years of studying the cosmos, we still do not know what exactly is concealed in its depths. However, even now it is possible to enjoy a wonderful galactic journey across great expanses of space in a multiplayer online game, Star Trek Fleet Command. Explore a vast open world, conquer new planets, and upgrade your fleet to join a spectacular battle with millions of players around the world. Get together a team of loyal allies, including completely new characters from the latest update. For example, the charismatic engineer Trip Tucker will boost the team's morale, while the pragmatic and tough Vulcanian T-Pole will be a trustworthy asset in difficult battles. These heroes will definitely come in handy in dealing with 10 missions from the new plot update Core ST Enterprise. For a smooth induction into the game, we're giving you a special promo code for newbies. When registering, use Warp Speed to get a content pack, which grants new players 10 epic shards of Kirk for free. Click the link in the description or scan the QR code from the screen and set out on your space adventure. In terms of the vastness of the cosmos, our planet is just a small rocky fragment, traveling at incredible speed through boundless emptiness. For billions of years, it has been orbiting the Sun, maintaining a distance of about 150 million kilometers. However, the true size of our system is much larger. According to modern concepts, its outer boundary, which is considered the far edge of the hypothetical Oort cloud, is at a distance of about 100,000 astronomical units. Beyond this boundary begins the vast abyss of the interstellar vacuum, space so rarefied that there is on average only a single hydrogen atom per cubic centimeter. The distances between the nearest stars in our part of the galaxy are a matter of a few light years, and a photon that has left the Sun can reach Proxima Centauri without ever colliding with a particle of matter. This vast void is a pervasive and integral part of the deep structure of the cosmos. It permeates the entire Milky Way, separating stars and planets, black holes and white dwarfs, super-dense pulsars and scattered nebulae. If you move outside the galaxy, you can see that it is surrounded by an even deeper vacuum. For example, between us and the Andromeda Galaxy lies 2.5 million light-years of exceptionally rarefied space. This distance is so great that 25 galaxies like ours could fit in it, yet it is filled only with the deepest cosmic vacuum. And this is only a small part of the great cosmic abyss. The Milky Way, the Andromeda Nebula and the Triangulum Galaxy, as well as about 100 of their satellites, are bound together by pervasive invisible threads of gravity. This structure is called the local group and is a large cluster of cosmic matter about 10 million light-years in diameter. The local group, in its turn, is part of an even larger formation, but a relatively small galactic filament by the standards of the universe, called the local sheet. This flattened structure, consisting of several hundred galaxies, has a diameter of about 46 million light-years, and its thickness is roughly 5 million light-years. The sheet is also part of an even larger association called the Virgo Supercluster. However, very close to the local sheet, outer space suddenly changes its appearance. Here, the usual colorful universe is harassed by a giant black abyss known as the local void. In fact, the local sheet is one of its walls, the other conventional boundaries being the Perseus-Pisces supercluster and the Pavo-Indus supercluster. At the same time, the void is divided into conventional parts by several rarefied galactic filaments, and wide passages link it into a single network with the neighboring Sculptor and Hercules voids. Due to the cosmological expansion of the universe and the gravitational influence of the surrounding matter, the volume of the local void is slowly increasing. At present, its diameter is about 150 million light-years, and the distance to the center is at least 70 million light-years. Meanwhile, the nearest edge of this cosmic void is located very close to the Earth, at a distance of about 3.2 million light-years. Due to this proximity, the local void occupies a significant part of our planet's night sky, about 40%. The main plane of the Milky Way, containing many bright stars and large nebulae, covers the central part of this region from us. Still, its edges do remain accessible for observation. In 1854, a dwarf spiral galaxy was discovered a little north of the constellation Hercules. It was dubbed NGC 6503. Later, with the advancement of observation techniques, it became known that it is located in the middle of the local void, and its distinguishing feature is the incredible multicolor appearance. The spiral arms of the galaxy are permeated with bright red clots of heated hydrogen, and shining blue nebulae are stellar nurseries. The center is obscured by clouds of cool gas and dust, which have a noble brown color. NGC 6503 has a diameter of about 30,000 light-years, and its distance from Earth reaches 17 million light-years. Due to the gravitational pull of the Virgo Supercluster, this galaxy is approaching us at a speed of about 43 kilometers per second. It is believed that its gradual approach to the local sheet will eventually saturate its space with interstellar hydrogen, causing an increase in star formation. It is estimated that in a few billion years' time, the current number of young stars could double, and the small galaxy will shine with renewed vigor. The motion of NGC 6503 is a clear demonstration of how the voids are likely to have come about. It is believed that the foundations of the large-scale structure of the universe were laid in the first minutes of its existence, at the time of chaotic mixing of matter and energy. Cosmic cataclysms of incredible power shook the young universe, forming local compactions and voids. Subsequently, clots of matter became proto-galactic clouds, and areas of space of reduced density became voids. Over time, the pervasive influence of gravity intensified this contrast, pulling stars and cosmic gas into relatively dense clusters, making the space and voids even more rarefied. Observations show that the vast majority of galaxies formed between 10 and 13 billion years ago. In addition, no significant differences have been found to exist between the age of galaxies located in voids and those that form global filaments. This fact also confirms the modern theory of the formation of the large-scale structure of the universe. Meanwhile, allowing for the cosmological expansion of space, we can assume that with time, the local void will become larger and more rarefied, and the Virgo supercluster will gradually disintegrate into several independent groups. At present, it is an association of about 30,000 galaxies concentrated in a region of space with a diameter of about 200 million light-years. At the same time, the total mass of the cluster is about 1.5 quadrillion solar masses, which is tantamount to about 1,000 galaxies such as the Milky Way. The Virgo supercluster is partially contiguous with two other galactic superclusters, the Centaurus and Pavo-Indus superclusters. At the same time, its other side borders on a vast region almost devoid of matter. It is called the Taurus Void and is one of the largest known cosmic voids. It is rather difficult to study this part of outer space. The reason is that most of the void lies in the so-called zone of avoidance, a sector closed off from us by the Milky Way plane. The bright stars in our galaxy outshine the fainter and more distant sources, and interstellar matter absorbs and scatters their light. However, thanks to infrared studies, we do have some ideas about the structure of this void. The diameter of this tremendous void is about 200 million light-years, and the distance to the center is about 150 million light-years. When observing the void, one is immediately struck by the remarkably clear boundary between the relatively empty space and a bright cluster of galaxies located much further away. It is called the Perseus-Pisces supercluster and is one of the largest in this part of the universe. A transition this sharp is characteristic of dust clouds, even though infrared studies do not confirm their presence. In all probability, the clear boundary between the void and the supercluster is caused by gravitation, but the exact mechanism of their action still remains to be found out. Meanwhile, it is thought that the Taurus Void, like most other cosmic voids, is not quite as empty as one might imagine. The way light passing through it is distorted suggests that this region may hide in its depths giant gas and dust clouds, the cradles of future galaxies. According to other hypotheses, huge masses of dark matter, the most mysterious substance in the universe, the properties of which are still not fully understood, may be contained inside the void. According to the most daring ideas, there are clots of antimatter or even more exotic matter with negative mass in the centers of cosmic voids. Nevertheless, despite their boldness, these hypotheses lie outside the boundaries of generally accepted scientific concepts, which makes it difficult to verify them experimentally. Currently, only 2 separate galaxies have been discovered tucked away in the space of the giant void. One of them, UGC 2627, has a spiral structure and resembles the Milky Way, while the second, known as UGC 2629, is an elliptical dwarf galaxy. Both objects are located almost in the heart of the void, at a distance of about 185 million light-years from us. The distance between them is small and is within a few 100,000 light-years. Perhaps there are other single galaxies hiding in the space there, but the Milky Way disk does not allow us to see them. Meanwhile, the Virgo Supercluster, together with 4 other superclusters, forms a giant galactic filament called Laniakea. It contains more than 100,000 galaxies and stretches for more than 500 million light-years in space. Its gravitational center is the Great Attractor, a mysterious supercluster of galaxies located 250 million light-years from Earth. In its turn, Laniakea is part of a vast galactic stream, and further out, one can see that most of it is surrounded by a black abyss of unprecedented proportions. The light of distant galaxies is drowned in its emptiness, and even the mysterious and elusive neutrinos take billions of years to cross this cosmic abyss. To be honest, it is hard to believe that despite all the development of observational technology, such a gigantic void was noticed only 10 years ago. The year 2013. The University of Wisconsin-Madison. A team of astronomers led by Professor Amy Barger is working to determine the distance between galaxies. In the process, an unexpected and staggering fact is discovered. It turns out that Laniakea and most of its surrounding superclusters are enveloped by a cosmic void of unprecedented proportions. After making calculations, scientists discovered that its diameter exceeds that of any previously known void. The size of the discovered void turned out to be so enormous that several fundamental cosmological principles were questioned. It appears that the universe is much more elaborate than we imagined. The research done by Amy J. Barger, Ryan Keenan and Lennox Coey has led, in all likelihood, to one of the greatest astronomical discoveries of recent years. Their work has shown that our galaxy, along with its surroundings, is located in the middle of the largest supervoid known to science. It was named KBC, after the first letters of the discoverers' names. Observations show that the shape of the giant void is close to spherical, and its diameter may exceed 2 billion light-years. According to calculations, the Milky Way is located a few 100 million light-years from the conditional center of the Great Cosmic Abyss, and about the same distance from its edge. The discovery of a giant bubble of emptiness surrounding Laniakea helped to explain the paradox that had kept scientists busy for many years. The fact is that all galaxies in the universe are gradually floating apart due to cosmological expansion. Measuring the speed of this motion allows us to calculate the so-called Hubble constant, a fundamental physical constant characterizing the rate of expansion of space. However, if we take the galaxies closest to us to calculate the Hubble constant, it turns out that the rest of the universe is expanding too slowly. On the other hand, if we take distant objects as the basis, the Milky Way's surroundings are moving faster than they should. The discovery of the void has accounted for a lot. The fact is that the galaxies inside it, including the Milky Way and its neighbours, are constantly experiencing additional gravitational influence from objects outside the void. This creates an additional force that gradually stretches our cluster in different directions. It is also surprising that the KBC Void is so huge that it comprises not only superclusters of galaxies, but also other voids. For example, the local void, as well as the Taurus Void, are part of its structure. It turns out that compared to other voids, even though KBC looks large, it isn't quite so empty. Nevertheless, according to calculations, even this void is just a barely noticeable dark spot against the background of the observable part of the universe, the diameter of the latter reaching 92 billion light-years. If we look at the global map of the universe, we will see a lot of dark spots on it, close to the KBC void in terms of their size. Most of them easily fit within the framework of modern physical theories, while others show surprising and strange properties, difficult to explain from the point of view of science. And one of the most noticeable riddles of this kind in space is the Eridanus supervoid, also known as the CMB cold spot. It is estimated to have a diameter of 500 million to 1 billion light-years, and it lies at a distance of between 6 and 10 billion light-years from the Milky Way. This means that this formation is one of the most extensive elements of the large-scale structure of the universe. The void is located in the southern hemisphere of the Earth's sky and occupies an impressive area on it, several times larger than the full moon. However, it is impossible to see it with the naked eye. The CMB cold spot is visible only with the help of special telescopes that study the cosmos in the microwave spectrum. Thanks to these, astronomers have discovered that within the spot, relic CMB radiation of the universe is about 70 microkelvin colder than the metagalactic average. This deviation is nearly 4 times as intensive as the strongest anomaly previously recorded, and its gigantic size makes it a truly enigmatic object that requires extensive study. It is now believed that relic CMB radiation traveling through hundreds of millions of light-years of deep vacuum is gravitationally influenced by distant galactic superclusters This causes the pervasive echo of the Big Bang to lose energy, making the CMB cold spot appear cooler in images than its surroundings. Nevertheless, this effect cannot fully explain the excessive cooling of relic radiation. According to calculations, the attraction of external galaxies can account for only a quarter of the observed deviation. It is assumed that the remaining 75% of the effect may be due to the impact of hypothetical dark matter or dark energy concentrated in the depths of the void. However, it is going to take a while before we can truly unravel this cosmic mystery. As we observe the cosmos, we see hundreds of millions of galaxies scattered in space, each comprising billions of all kinds of stars, trillions of planets, and countless other celestial bodies. This infinite diversity creates gigantic cosmic structures, covering space with a glowing network. But all this is but glittering dust against the great void that fills the universe. This void is the true cosmos, mysterious and dangerous. Maybe in its depths are hidden answers to the key riddles of the universe. Or maybe there is nothing but endless darkness, hardly comprehensible to the mind. Only time will show whether one day we will get to the bottom of its secrets.